This section of the book, 2.5, talks about measures of position. Keep in mind that we've talked about measures of central tendency, which was what? What do you remember? Measures of central tendency? Close. Mean, median, mode, right? Then we talked about measures of variation, which was range, right? So today we're talking about measures of position. Where is the data in the list? Where is it? Okay. Now, this talks about quartiles. Okay. What I want you to realize, I'm going to jump around the section just a little bit. I want you to realize that quartiles is not the only kind of measure of position we can talk about, but that's the one that's mostly used. Okay. Fractiles are the number of that partition or divide the ordered sets into data. So besides quartiles, we could talk about deciles or percentiles. This would divide it into 10 equal parts, and this would divide it into 100 equal parts. We obviously don't want to do percentiles if we only have like 20 pieces of data, right? Because it's going to divide it into 100 equal parts. That's when you have a whole lot of data. Okay? Deciles, again, you don't want to just have 20 pieces of data because that's only 2 things of data in each part, and that doesn't really tell us a whole lot. Okay? So we talk mostly about quartiles. All right? Now, you have actually talked about a quartile without even realizing it yet. Okay? Because if you have quartiles 1, 2, and 3, wouldn't quartile 2 be the one right in the middle? Right? If you have, it's a total of 4 sections, wouldn't quartile 2 be right in the middle? Well, what's that called? What's the number that, yeah, that's exactly right. The number that's right in the middle is called the median. Okay, so we've actually talked about quartiles, we just haven't focused on the actual mathematical name of quartiles. Okay, so quartile 1, first quartile, we're going to use Q sub 1 to notate that. Okay, so obviously then Q sub 2 and Q sub 3 would be quartile 1, quartile 2, and quartile 3. Does that make sense? Why don't we have quartile 4? That's just the end of the data set, isn't it? Okay, so we just really, these are the dividers. These divided into four sections. Okay? So let's talk about this specific example right here, finding the quartiles of a data set. Okay? Now, I'm not going to do this one. I'll do the next one because this is pretty much all already done for you. Okay? To find the quartiles of a data set, first of all, we list at least to greatest. We need to do that anyways because we're trying to find the median. In order to try to find the median, you have to find the one in the middle when you list at least to greatest. Okay? So once we find the one in the middle, first of all, that tells us our median, but we also call that quartile 2. Okay? When we find our median, we then have 2 halves of data, the first half and the second half. You okay with that? What if there were 2 numbers? You know, sometimes there's an even number of data and we have to take the 2 numbers in the middle and find the mean of that to find the actual median. If this, like, let's just say these 2 were the ones in the middle. Then I would take this one and it would go down into the bottom half. Does that make sense? And then the 20 would come into this top half. For now, this doesn't really lie in either half because it's one number. That's where the median is, right? So then I look at the bottom half of the data. And when I look at the bottom half of the data, I just find the median again. All right? I look at this number of terms and I've got 7 terms here, so that 4th term would be the middle, right? Well, that's quartile 1. That's the dividing point of that first half of the data, so that's quartile 1. Quartile 2 then is the dividing of all the data, the one right in the middle. And I do the same thing for the top half of the data. Find the median, and that's my quartile 3. That's the divider of the data. Okay? Does that make sense? Like how to do it by hand. Okay, so here's the deal. Let's interpret this. What does it mean? What do quartiles mean? What are they used for? Okay, about 1/4 of the countries, if these are countries, which we didn't read at the top, but it talks about 15 nuclear power plants or nuclear power producing countries, excuse me. Okay, so what do we observe? Well, about 1/4 of the countries have 9 or fewer nuclear power plants. Does that make sense as far as interpreting this data? Tell me how many half of the countries have how many nuclear power plants or less? 16, right? That's the quartile 2. How many of the countries have 33 or fewer power plants? That's 3/4 of the data, right? That's 75% of the data have 33 or fewer nuclear power plants. And then we've got this, like that's all of the total, right? That's why we don't have a quartile 4, because that's the end of the data. Does that make sense now? I know I said that a minute ago, but now that you can see it, does that make more sense? Okay. Example number 2. Okay. Using technology to find quartiles. We like to use technology when we can because it's a time saver, okay? I just showed you how to do it by hand so you know what's happening in the calculator, right? That's been my rule for years and years and years. As long as you know what's happening, I'll let you use the calculator to figure it out, right? So let me show you what's happening here, okay? I'm going to go home. Not actually, because I have a lot of stuff to do today. But I'm going to go home to a new document. No, I don't want to save my old one. And I want to go to a list and spreadsheet. I know that you think we should always go to statistics because this class is called statistics, right? Not this time, okay? We have to do a list and spreadsheet for the kind of information that we're trying to find, okay? Now, give me just a second. This is what's going to take the longest, I promise, okay? Give me just a second. Let me get this data into the calculator. 38, 33. You could actually be practicing right now along with me. Thank you, Caitlin and Casey. 38, 33, 40, 42, 34. Oh, sorry, I'll move my hand so you can read what I'm putting in. Okay, you have all your data in? Yes? Okay, so remember with our, oh, I'm sorry, hold on just another second. With our little cursor thing that's not really a cursor, but with our highlighted one right below the list of data, before I do this, something I always try to do is check a little bit. I don't want to take the time to go through and check every single number, so I try to be careful in the first place. But one really easy check is to realize that we're talking about 25 liberal arts colleges. How many data entries should I have? 25. So you can look and see my last data entry is at 25. That's an easy check for you to do, okay? I'm going to zoom in real quick so you can see my calculator after it turns back on. Okay. Thank you, calculator. Okay, so I have the calculator. So in that bottom, focus, you can do it. Okay, in the one right underneath, where am I going to go first? Do you remember? Menu, statistics. Now, pretty much everything else from here on out is just an enter, but let's make sure we understand what we're doing. We're trying to find some stat calculations. We want one variable statistics. I'm only using one list, so okay. And then I'm using list 1 with a frequency of 1, okay? I don't need oh, I'm putting my results in column B. That's what it's saying right there, okay? So I just press OK again. Now, I don't see anything right here because everything is up at the very top of this column. So I need to scroll up a little bit so I can figure out what all it told me, okay? So let's look at what it told me. First it's saying here's the title and here's the one variable statistics. It's giving me information to use to tell me where everything is. Okay? So what does X bar mean? Mean. That's my mean. My mean is 33. Okay? Did I have to add up all those numbers and divide by 25? No. With our technology that can help us do that. Okay? What does that mean again? Do you remember? What is the sigma? The sum of the x's or of each data point. So the sum is 825. Okay, so if I took 825 and divided by 25, I should get 33, right? Okay, then this is the sum of the x values squared. Each x value squared, and then I add those together. That's the sum of that. Okay, now from what I can figure out, you guys know this is a little bit new to me. Okay, but from what I can figure out, this sigma x, this is the standard deviation that we want to use. I honestly do not know the difference between these two yet. I'm trying to find that out. Okay, because S in our book at least says it's standard deviation for a sample, and this lowercase sigma x, it says standard deviation of a population, right? Now we know from our problem that there's not just 25 liberal arts colleges, so we know that this is a sample of the entire population, right? But I don't know how the calculator knows that. But I do know in doing this, figuring out this by hand, this is the standard deviation that we want to use. Okay? I promise I am still looking into that. I'm not going to let it go until I figure it out so I can tell you guys. All right? So that's what that is. Then we have n. What's n again? Number of entries, right? Then we have min-x. That's the minimum value. It's the lowest value in my list. Oh look, quartile 1, median, quartile 3, maximum. Isn't that nice that it does it all for you? And then we have SS. Do you remember what that stands for? Sum of squares. Do you remember that? Okay. We talked about that a little bit back in yesterday in our section where it talks about here about sum of squares, and it's denoted by this SS sub x. Okay, it's the population variance. The average of the sum of squares is the population variance. Okay. Any questions about any of that stuff on the calculator I just showed you? Okay, we're going to let the calculator do a lot of this work for us because we have proven that we understand the math that's going on behind these things. So we're not going to let the arithmetic slow us down. We're going to let the technology help us out. I honestly cannot think of a job, maybe Mr. Clemens can help us out. I can't think of a job that you would have where you'd have to be finding this information that you wouldn't have a calculator at your disposal or a computer program already at your disposal. Okay? Any questions about finding quartiles either by hand or with the calculator, with the technology? You good? Okay. An interquartile range kind of makes sense for us to be able to know how to work with, or even know that it's there. And that's, you know, a range. You already know that because we talked about that yesterday some. We're going to do some subtraction, right? Excuse me, but the range. An interquartile range is quartile 1 minus quartile 3. So it's the two interquartiles, all right? Now, read here with me. It says that it gives the range of the middle portion of the data. So about half of the data you know the range of. Do you see where that might be useful? Well, for one thing, it can help us find outliers. Okay? We talked a little bit about outliers the other day, numbers that are just really far from the main core of the data. And we also talked about the fact that later on we would talk about more about what outliers do or how to find outliers more mathematically. Okay? We use the interquartile range to find them more mathematically. Okay? Than just saying, yeah, that looks like it's farther away than it should be. So to find the interquartile range, or to use the interquartile range, here's another guidelines box. You guys know that I think these guideline boxes are pretty cool because they kind of take you through steps little by little. Okay, so to use the quartile range to identify your outliers, you're going to find quartile 1 and quartile 3 first of all. Okay, then find their range, the interquartile range. Multiply the interquartile range by 1.5 so that it looks like 1.5 times whatever you got for your interquartile range. Okay, subtract that from your quartile 1. That will tell you any that are too low to be outliers. Add 1.5 times your interquartile range to quartile 3 to see if there's any outliers too high above any of the extra data sets. Okay. Now, if we go back to this first example that we talked about, and I said to you, are any of these numbers outliers? Well, let's put them in order. these might be easier to see. Are any of these numbers outliers? What would you say? What do you think? 104 maybe, right? That would be a guess, right? Is because 6 we're not really an outlier because it's right next to 7. There's not outliers in the middle of the data for sure, right? So it's either on one end or the other. Well, we've got 33 and then 50 and 58 and then suddenly 104. Okay? So we think that's probably an outlier. We can use the interquartile range to determine if it's actually an outlier. Okay? Now, we already said we don't think there's any too low, right? But if you take quartile 1 and subtract 1.5 times the interquartile range, that gives us negative 27. Are there any numbers lower than negative 27 on this list? No, in fact, there's no negatives at all, right? Okay. But if we take the quartile 3 and add it to this number that we've discovered that's 1.5 times the interquartile range, we get 69. That means any number that's greater than 69 is officially an outlier. So do we have officially an outlier? Yeah, 104 is definitely an outlier because that's definitely greater than 69. Yes? Box-and-Whisker Plots. Have you ever heard of Box-and-Whisker Plots before? Anyone? Have you ever seen a Box-and-Whisker Plot before? Looks familiar. That's okay. In the Texas Teaks now, I think they've pushed the Box-and-Whisker Plots down to like 6th or 7th grade. It's another one of those things that you guys missed. Because for a long time it was at geometry level, 10th grade level, and then they moved it down to 6th or 7th grade level right when you guys were in the middle. Your group of grades were right in the middle. So you didn't see it in 6th or 7th because it was in junior or sophomore year. And then when you got to sophomore year, you didn't see it then because they'd already moved it down below you. Does that make sense? It doesn't make any sense to me, but whatever. They didn't ask me, right? Okay. So here's a Box-and-Whisker Plot. The cool part about Box-and-Whisker Plots, first of all, it's supposed to look like a cat. I have never seen a cat with one whisker on each side. And if I did, I think it would freak me out. Just being honest. Okay. But we use our minimum. Oh, nice. We use our minimum, we use our quartile 1, we use our median, we use our quartile 3, and we use our maximum. Where did it come from? She said no. She told no. Okay, thank you. Just down there is good. Thank you. Awesome. And interesting. Okay. Okay, so sorry about that. Back to Box-and-Whisker Plots. Minimum, maximum, your two quartiles and your median. Okay? Now, you guys know me. You guys know what a visual learner I am, right? This lets me see visually the important features of my data set. Where is a lot of the data? Now, half of it should be in between the quartile 2 and quartile 3, and half of it should be between quartile 2 and quartile 3 and quartile 1 and quartile 2, right? This should be half of the data. But it can help me see how long this whisker is compared to how long this is, and how long this is, and how long this whisker is, right? Now, are these two whiskers right here the same length? They're not, are they? Do they have to be? No, it's a fourth of the data. So this might let me know that the data in between these 2 points, there's a whole lot of data in just a short amount of time, or a short amount of numbers, and this is more spread out. This data is still a fourth of the data, but it's a little bit more spread out because the whisker is longer. Does that make sense? It's a visual representation of some important features of the data. Okay? Any questions about that? It's another application to use our quartiles in. All right? But, I mean, this shows you how to draw a Box-and-Whisker plot, but if you know all 5 of these data sets or all 5 of these data information, could you pretty much draw a Box-and-Whisker plot? Yeah, okay. The percentile that corresponds to a specific data, oh, you can't see that, sorry. A percentile that corresponds to a specific data entry gives you another formula, okay? I know that this week we're almost formulaed out with all the formulas that we learned last week and then the week before that, but we're going to be okay, right? If we're not, I got tissues on my desk if there's crying happening. We're good, okay? So right here we say the percentile of X a specific data entry is the number of data entries less than that divided by the total number of data entries. Guys, doesn't that sound like a percentage anyways? Isn't that how we find a percentage anyways? Okay, so that shouldn't be something that's really difficult or anything to understand, because you already know how to find percentages. Okay. Last thing I want to talk about is a z-score or a standard score. Okay. Here's one of those formulas that we talked about a little bit yesterday. It's not exactly one that's yesterday, but like it because it has all these symbols in it. So the hardest part for us is going to be remembering what each of these symbols mean. That's why I'm glad they gave us one with words this time. Okay, the value of the data, the individual data piece, minus the mean divided by the standard deviation. We know how to find all these because especially standard deviation we talked about yesterday. Okay, but the value minus the mean divided by the standard deviation. The z-score or the standard score, it can be positive, negative, or 0. When z is negative, it's because that x value is less than the mean. So that means when it's positive, what's happening to that x value? Say it out loud. It's greater than the mean, right? Okay, and what happens when z is 0? It's equal to the mean. You okay with that? Okay, any questions about that? All right, so that is your topics that we talk about for 2.5. That will be in your homework for section 2.5 on My Math Lab. Do you have any questions about any of those formulas or definitions or any examples you want me to do or redo? Or you want to just get to work on your homework? Get to work? All right, get to work then.